All right, hello people watching this. Chapter 5 review. We're going to go through the ones that I have circled here because these are the ones that people said that they were able to kind of get through yesterday. So we're just going to go through and check their stuff, and then tomorrow when everybody's back together, we'll go through the rest of them and test who knows when. Friday probably, because you guys are gone on Thursday for one act again. So here you go. Number 1, the braking time of a car. Okay, we're talking about time. Circle that word. Circle the word time. Time is in seconds or in milliseconds or fractions of a millisecond. Is that discrete or is that continuous?
Continuous.
Continuous, because it is a decimal that goes on forever. Discrete means countable. And yeah, we can count in seconds, but like the decimal for seconds and milliseconds and stuff goes on forever. What? So continuous, that is a continuous period of like measurement, right? Any questions about that? Number 2, match the following values as discrete, continuous, or not a random variable. Now, in order to be discrete and continuous, it has to be a number, right? If it's not a random variable, it is probably a categorical number or categorical value, let's say. So maybe write that down. So not a random variable would be anything that has categories, right? So the exact weight of quarters, I'm going to circle the word weight because that's what we're talking about, okay? Is weight discrete or continuous?
Continuous.
Continuous, because you could be like 5 pounds or 5.3 pounds or 5.37426 pounds, whatever, right? So that is B, continuous. Shoe size
Discrete.
of humans. Yeah, I would say discrete because that is a, well, shoe sizes though, because that might be a category. If we're talking about the number of people that have each shoe size, then I would say maybe it's discrete. I don't know. Did anybody say not a random variable for that one?
I think we also have A. I have an A as discrete.
That, if I would give you that on the test, I would probably take A or C. Because technically, shoe size.
We put C for the next one because
yeah, C is a that's definitely C. But yeah, I could see how somebody would maybe. I would probably go with A, but I could see how somebody would maybe argue C because shoe size is kind of a category, I guess, even though it's a number, but it's kind of a category. So probably A, but if you had C, I'll probably take that too. Okay. Hopefully the one on the test.
Yeah, I wouldn't think about it that hard.
You wouldn't think about it that hard? Okay. So most of you guys probably had A then. And that's fine.
He had A.
Hopefully the one on the test will not be, it'll be cut and dry. It'll be not a weird one like that. Okay? All right, let's skip down to number 4 because you guys said you had tried number 4 for the binomial distribution. So if you're looking on your yellow sheet, you're looking under binomial, which has the stated values of n and p. Round your answers to the nearest hundredth. Find the standard deviation. Okay, so you should be on your yellow sheet under binomial distribution, standard deviation. You have a formula for it. Standard deviation is this guy, and it's something like, is it like the square root of NPQ? Mm-hmm. Yeah, it's just that formula, right? Okay, so practice looking that up on your yellow sheet. It should be under binomial, which is 5-2 section, and you're looking for standard deviation. Square root of NPQ, okay? N is 503. P is 0.7, that means Q is 0.3. So,
I got 10.3.
And you got 10.3? Anybody want to check her or do we believe her? I'm pretty sure I believe her. Yeah, I think so. Yep. Okay. All right, the next one, find the mean for the binomial distribution, okay? That has values of n and p, round your answer to the nearest tenth. So this should be in the same area. I'm going to get rid of that box. I'm going to do mean for binomial distribution. Should be in the same area for the formula as the standard deviation was. Kind of in the same area on your yellow sheet. But what this is saying is that I have 676 people, let's say, and 70% of them are behaving a certain way. How many is that on average, right? To find the mean or to find the average, I take my n times my p. Like if 70% of the total is doing this, how many is that, right? So 576 or 676 times that 70%. Is that true? Is that the right formula?
Mm-hmm.
Yeah?
473.2.
473.2. Now, we don't necessarily know that we're talking about people here, so I'm going to leave that 0.2 on there. If we were talking about people, we would maybe like round to the nearest whole number or whatever, you know. But 473.2 we'll just leave. That's the average number if 70% of them are doing a certain thing. You see how that works? Okay, go to 6. Find the standard deviation. Hey, this is another one. What the heck?
Yeah, and there's another one.
And there's another one. Whoa, you better know standard deviation then, I guess. I don't know. Standard deviation for binomial. That is sigma, the square root of NPQ. Okay, now n is 38. P is 2/5. I don't like 2/5 because I don't like entering 2/5 into my calculator. What's 2/5 as a decimal? 0.4. I'm going to change it to 0.4. You don't have to, but I'm going to. Q is 0.6. So 0.4, 0.6 times 38 and the square root of that. Anybody got the answer?
3.02.
What?
3.02.
3.02?
I should probably have checked.
0.24.
Yeah, 3.02.
Yep, that sounds good. Okay, good? Questions about that? Standard deviation. All right, let's go to number 10. Here we go. Assume that a procedure yields a binomial distribution. Okay? All right, so we're still in section 5.2, binomial, right? We get to a point where we start talking about like the Poisson distribution or whatever that is, right? That's like section 5.3. We're still in binomial. So it says, with the repeated trial of n equals 30, I'm gonna write that down over here so I don't have to reread it. N equals 30, 30 trials. Use the binomial probability formula. What is that?
NCR is equal to, or
NCR
times
P to the R, Q to the N minus R. That's the binomial probability formula. To find the probability of 5 successes, they call that X. I switch it to R usually, because NCR, it would be like NCX, whatever. The probability of success is 1/5, which as a decimal is 0.2. They don't tell me what Q is, but I can subtract 0.8. Okay. If I have a 20% chance of success and I have 30 trials and I want like, what's the chances of me getting 5? You think that's going to be like really, really super low? Like a decent amount? 20% chance of success. Any guesses? Like if n is 30, I have 30 trials and I want 20 of them are going to yield success, right? What is 20% of 30, by the way? 6? 6?
Yeah.
0.6? 6. Okay, so 20% of 30 is 6, right? So me getting only 5 successes rather than 6 successes, that's not very much off from that, right? If the average would be 6, right? Like n times p is the average, right? We just calculated that up above, right? Mu is equal to n times p. Okay, if we do n times p, that's 6, right? If this number was actually like, I don't know, 28, what's the chances of me getting 28 successes when the average is 6? Probably pretty low. Does that make sense? So these are things that I would like try to like figure out in my brain maybe. Because like if you get an answer that's like super like 0.00000 and you're like, oh, I must have screwed up. No, not necessarily, because if they're asking for 28 and the average is 6, that's going to be a really low percentage of chance of happening, right? Okay, so let's plop it into the formula. N is 30, C 5, P is 0.2 to the, okay, I've got 0.2 and 0.8. 0.2 to the what power? To the 5th. 0.8 would be to the 25th, because these two numbers have to add up to be whatever this is, right? Okay, I would really strongly encourage you practicing plugging that in at some point before you take this test so that you know how to do it.
0.1723.
0.1723. That as a percentage is 17.23%. Is that a low percentage, a high percentage, a decent one? It's a decent percentage, right? Like 17% is a decent chance of it happening, right? Which we said was probably true. If their average is 6, the chances of me getting 5, yeah, that's reasonable. 17.23%. I don't care if you leave it as a decimal or convert it to percent, whatever. Okay? Good, good? That was 10. Let's go to 14. This is another standard deviation. I don't know why I give you so many of these.
Can you do these on the test?
Yeah, can I give us a bunch of these on the test? Standard deviation for the binomial distribution. Okay, you should have this formula memorized. The square root of n PQ, right? Okay, n is 48. P is 3/5. What is that as a decimal? 0.6. P is 0.6. That means Q is 0.4. You can leave it as a decimal. I'm not, you know, whatever. But I would rather type in 0.6 than 3/5. Because like typing fractions into my calculator gets messy sometimes. So anyway, if you do that, I don't know.
3.39.
3.39, perfect. Okay, all right. Okay, this one doesn't tell us what to do. A tennis player makes a successful first serve 51% of the time. If she serves 9 times, what is the probability she gets exactly 3 successful serves in, and assume that each one is independent of the others, right? So like she doesn't get better as time goes on. This is not meant to confuse you. It's trying to make things easier on you. So whatever. What are we going to do here? N equals 9. Got it. Okay, what's some other stuff? R is 3, right? Okay, what else you got? P is 0.51. Got it. So I just start pulling out information, and then it's kind of clear what you do. Q is 0.49. So how do we calculate this? The formula, right? NCR. NCR, P to the R, Q to the N minus R, and 9C3, 0.51 to the third power, 0.49 to the, what power is that one? 6th, right? Because 3 and 6 has to add up to be 9, right? Okay, if you do that, 0.154, is that a decent probability?
Probably not.
15.4% chance
That's okay.
that she has exactly 3. Okay, now, hold on just a second. 51% of the time she has a successful first serve and she has 9 serves, right? 51% is about half. Half of 9 would be about 4.5, right? So the average would be about 4.5-ish, right? So if she, on average, would serve 4.5 serves in, what's the chances that she only serves 3 in? That's not like way far off from 4.5. So this percentage is not going to be like 0.000 something, right? If they said on average she would serve 4.5 out of 9, and you would have like all 9 serves in. She has a 51% serving percentage, and what's the chances that she serves all 9 in out of all 9?
She just had a good day.
She just had a really good day, but the chances of that happening are probably not going to happen, right? Like that's going to be a probability that's going to be like really, really, really low, right? So this one is decent, 15.4%, because 3 and 4.5, like 3 is not very different from the average, right? Makes sense? Good, good? Is there anything else that's like that?
Nope.
You're going to say, no, nope, we don't want to, right? We're done.
I'm too tired for this point.
That's a mean. Some of these are not too bad. Find the mean. Okay, yeah, those were all of the binomial ones, so that was good. Okay, all right, there you go. We'll stop for the day.